So we're going to look at the lighting and shaders here a bit more. And regarding the assignment number 4, or the lighting and shader part of the maze assignment, when you make the document that you're supposed to return, make sure that you explain everything that's important there, and don't kind of skip over what you feel is obvious or what you feel is done exactly like I do it, because particularly the code and the shaders that you do just exactly like me, make sure you show me that you understand what that's doing. So it's not about you just explaining what you added or what your take on it is. It's about you showing me that you truly understand everything that the shader is doing and how it's used and how the calculations are, because that's what this assignment is about, more than you spending a lot of time coding a complicated shader. So you have some starting point in these videos, and in the examples in the lighting and shading lab exercise, I added those examples at the back with a little code for the shaders. So you have a starting point there. What you have to do is make sure you can make it work for more than one light. Once you have that, and you have the lighting you need for your project, your maze project, then the assignment is about making the document that shows me that you understand everything that your shader does. So explain how the shaders are working together, the fragment shader and the vertex shader, and show me that you understand all the lines. Also the lines that are just exactly like the base code that I give you. And actually in particular those lines, so that I can, because if I see a line that's just exactly as I wrote it and gave it to you and no explanation on that, obviously I'll just feel like that's something you just put in there and hoped it would work. So okay, just to make sure that the emphasis in this project is on showing that you understand the shader rather than you spending a lot of time making a complicated shader. Let's continue here. There's one thing here that we did last time. You'll probably not see it on the projector though, but hopefully it'll come out in the video. I'm setting the display mode, so I'm getting this desktop display mode, which is basically the resolution of my screen, or the screen that I'm using, and then I'm setting the display mode to a particular width, a particular height, and true here means that I'm setting it to full screen. So full screen is true. Down here I added an input as well, where I said if escape key is pressed, I set the display mode back to a window and exit. The reason I set it back to a window before I exit is because my graphics hardware was complaining that I exited too abruptly out of the full screen mode. So I'm setting it like this and then exiting, and then I don't get the... Let's see if it works both on the projector and on my screen. At least it's working on my screen now. So yeah, here you have a full screen mode that actually reads the resolution of your screen and then sets it to full screen mode. So you can send that. Did it ever show up on the projector? Yeah. Okay. So I'm going to take that out now for this demonstration here, but you can have that there. So what I've done since the last video is I took the code that we had set up in, so here in assets we have our shaders. I basically took the simple 3D shader and I called it fragment shader 3D, and then I made the vertex shader, and I basically took the code we made last time that we moved into basically making it per fragment lighting, and I split it up into 2. So what we're looking at now is the per fragment lighting, and we can see this weird error that's happening here, this weird extra light that's happening when the light source is behind the model. I'm going to show you how we can fix that. Just to emphasize, if we take the, okay, here we're doing the lighting in the fragment shader. So the reason this is happening is because we're only taking this dot product. We're taking the cosine of the angle between our normal and our S vector, and that means we can get negative values here. And I'm not going to go through this entirely trying to understand exactly when we're getting negative values that show up as that color. But if we simply do max of 0 and this, we can have it 0.0 and this, and the same for phone here. I'm pretty sure it's happening in the specular calculation, but it's supposed to be in this case both. So if we get negative numbers, we get a 0 instead. Just making sure that we don't end up with negative numbers there. And then we get rid of that weird extra light that's happening when the light is at the back side of the object. So okay.
Is the object spinning or is the light spinning?
The light is spinning. And in this demonstration now, I'm kind of going to add a few things to make it a bit clearer exactly where the light is. I'm going to add a way to draw something with only emission without it being lit. So we're actually going to draw the light source itself as a little model so we can see where it is. But yeah, the light source is spinning and the light source is also changing color. So it's all a bit weirdly lit right now after what we did last Friday. Okay. So I did this fix here in the fragment shader. What I'm going to do now is I'm going to, so these aren't great names here really. Fragment shader, this is a vertex shader and this is a fragment shader. The reason you should really call them just fragment lighting or fragment lighting shader 3D. So here in this shader set where we have a fragment shader and a vertex shader, we're doing the lighting in the vertex shader. So I'm going to switch to those. So in shader graphic I'm going to so I'm going to go to the let's call them vertex lighting instead, even if it takes a while to rename them. Fragment lighting 3D. Rename fragment lighting 3D. And then we have here vertex lighting. So we're basically, the difference between them is where the lighting calculations are happening. Rename. So vertex lighting, and we're going to go back to the vertex lighting and add the changes there. It's a nicer place to understand what's happening. So vertex lighting here, and we can actually see the difference then between what we had, this and what we had earlier. Okay, that error is there again because we haven't fixed it in this one. So let's start by fixing that. Vertex.
File extension is down there for.
Yes, the frag and the vert file extension.
It's still a YAML file. Or
no, it's basically just a text file with this file ending, but the code we put in there is basically C++ code, except we have a set of kind of pre-included functionality, like the dot product and all the matrix multiplications and a lot of functions that we have there. And there's a link to a quick reference of all of these different functions. Actually, one to a small quick reference and another link to a list and explanation of all these built-in functions in the vertex shader. But if we look at, so the vertex shader that does our vertex-based lighting is here. So the lighting calculations are happening here in global coordinates, and we have to do the same thing here. Max of 0 and this, and max of 0 and this. Okay, so we're not getting that error now, but we can see that this is very much different from what we had earlier. So one thing I'm going to do, I'm going to go into the sphere graphic and I'm going to make the detail in the sphere a bit higher so we don't have so, still you can see how we're getting this blink on the specularity, because it's calculating the specularity just at the points, just at the vertices, and when the highest specularity kind of lands in between, we don't get much there. However, if we were to go in here where we set our display function, where we set the shininess, so here we're setting the material, setting the shininess really, really high. If we set that lower, it's a little bit different, that shine spot, but it's still a pretty big and weird shine spot. And we can see kind of the edges of all the polygons in that model when we're looking at it. But in any case, we're gonna keep using this. Let's just make the sphere even more detailed. And get on with this. So okay, now we have a bit of a shine spot there. We can see on the walls here, since they're each just a couple of polygons, we don't see this actual shine spot happening there somewhere in the middle. Okay, so the first thing we did was just fix this error here. Make sure that when we're taking these cosines, that we're taking a max of the cosine in 0, so all negative numbers become 0. The next thing we want to do now is kind of split this up a little bit and make this a little bit clearer. So we're calculating these vectors. S, the direction to the light, V, the direction to the camera, H, which is the halfway vector between them, which would be a vector that would reflect it one perfectly into the other, or a approximation of that vector. I'm just going to make little kind of intermediate colors here just to make the code a little bit clearer. So let's say we have, let's start with diffuse, just a diffuse color here. It's calculated. Let's say that equals this part here. So we're taking the light diffuse and the material diffuse, and we're multiplying that with this factor Lambert here, which is the relation between the normal and the direction to the light. Then for specular color, and we'll take the other part here. So we're taking, so now we don't have any specular factor for the material, so we want to add that. We want to make sure that we have a light position here. I'm going to change this a little bit, and I'm going to say we're just going to use a light color. We're just going to say the light has a specific color, and the color of the light doesn't change depending on whether it's reflected or scattered. So a full light model, like the static pipeline would implement it, would have a specific specular color and a specific diffuse color for the light, as well as an ambient color. And I'm going to make the light simple and just say it has one color. We use that for specular and diffuse, and then we're going to add to that a global ambience. So we're going to say, going to add here a global ambient. So that's one factor, not per light, but just one factor for the entire room that we're calculating here. Okay, so we have this global ambient, we have a color for the light, we have a material diffuse, and we want a material specular. And we're going to use material diffuse for ambient as well. Okay, so we'll just look at how that works here. But down here, I'm going to say, instead of this vector 1, 1, 1, 1, I'm going to say U material specular. Here I'm going to use, if you want to have a separate specular value for the light, you'd say light specular here and light diffuse here, but we're just going to say, now we're just going to use the light color. So the diffuse color is this Lambert times the light color times the diffuse of the material. The specular color is this Phong value, which we calculate in the same way except using the H vector, the halfway vector. But we set that to the power of the shininess, meaning that the higher the shininess, the smaller this will be, because we're attenuating the actual strength that Phong is. So Phong gives us a strength between 0 and 1, and by putting it to a higher power, we're actually making the number smaller, meaning that this shine spot becomes smaller and smaller around the, we'll always have the same point where the intensity is highest, but how big that shine spot becomes is in relation with this material shininess. So the higher the shininess, the smaller the shine spot. Okay, then we have the light color and we have the material specular here. And if you want to have more lights here, then we'd say something like just light 1 calculated color equals this. And then you'd have to do basically this, all of this over again. Although this part here is just once, since that's the camera and the vertex itself. The camera and the vertex decide this vector, whereas the position of the light decides this. So this, everything after this will be for each light. We do this here. We can say right here, we can say and for each light. So we can then reuse these variables, Lambert, Phong, diffuse color, specular color. You can't redefine them, but you can just do this over again as many lights as you need. And then we come down here, we can just say, we're going to end up saying the actual color is going to be light 1 calculated color plus light 2 calculated color plus light 9 calculated color, so on and so forth, just for as many lights as you have in your model. So in order to make this a little bit clearer, we have this done for each light. We calculate the S vector first, and then we calculate the H vector because that uses the S vector, so that's once per light. Calculate Lambert and Phong, the diffuse intensity and the specular intensity. We can calculate these colors and add them up to this single light 1 calculated color. If we do this once for each light, we end up being able to have separate light calculated colors for each light that we can add up. Except we want to add up a little bit more to that. So we want to go here and say, in addition to the calculated colors for each light, we also want to say this equals global ambient times material. I'm going to use the diffuse value of the material just for this light as well. But you could have a separate ambient value for the material as well. Plus this. So I'm going to see if we can get this to work. We have to make sure now that our shader itself is using these same variables. So the variables we changed is that we added material specular. So material diffuse, material specular. We added, we just called light color this rather than light diffuse, which means that when we set these variables, we have to make sure that we're using here. So the variable in the shader called uLightColor will access that using this. Material diffuse, I'll just copy this line and say we're going to do this for specular as well. And then we need functions to access this. Okay, so we're going to say set light color here. And we're going to set material specular here. Okay, and then finally we actually need to set values to these. So here we're setting material diffuse. I'm going to try to make this just really shiny and say the specular color is going to be just full white. The shininess, I'm now calling this light color. There's one more thing we had there that we're not setting, right? Okay, yeah, set material specular should be here. And then we also added one more thing. Can anyone remember what it was? Nope. Private hint. That wasn't supposed to be there. Global ambience location. So there's a variable to access it. And let's take this here, separate it a little bit here. Global ambience location, and we had line global ambient. Okay, so then we need, so obviously the more of these we're adding, actually let's use this one instead. The more of these we're adding, obviously the more complex our shader class will be. So if we're, if we have a lot of lights, we might want to edit these functions a little bit, so they just take in an integer, indexing into which light we want to change, and then we'll have a little bit of if sentences and stuff in here, so it won't be as complicated to use this class. Okay, so set global ambient to a color, and we'll use global ambient location, and then in here let's set the global ambient to something. Let's just start by setting it to 0. Shader.set global ambient. Let's just start by trying this and see if we get this to run properly. Global ambient undeclared identifier inside the shader. Of course, here we should have it's okay like that, and material diffuse as well. The same thing. I forgot the u underscore here to mark it as a uniform variable in the shader rather than just a local variable. Okay, so this is working the same as it was, except we kind of want to see what effect the ambience has. So we can see that if we go to a backside here, everything is just completely black when there's nothing shining on it. So if we go in here and say, okay, let's set a value to this, something 0.3, let's just say there's this white light ambience on everything here. So let's see how that looks if we go to the backside. Does it not? Still pretty dark. Let's see in the shader itself if it isn't. Global ambient times material diffuse. Just to make sure that this is actually going through here. Let's just set it to something. No, it's not having any effect, is it? Let's find out where that's. Okay, set global ambient. Global amb location. Let's go to global ambient. There we go. Okay, that's too much. But let's go back to our original values. Just setting a small amount of global ambience here. Okay, so if we go to the backside here, we can still see the object itself. This is actually a little bit much. So let's set it lower. And you can see that if you were to have a separate ambient for each light source. As soon as you add a light source, it kind of becomes too much like that. What's happening now is that while we're walking around, we kind of see the whole dimensionality, the whole 3 dimensions of this structure. You see the structure itself better, even if it's not being lit specifically from the side that we're looking at. Whereas if we go back to 0 ambience, it's always just... But then again, make sure you don't take the ambience too high, because then you're kind of just drowning out the actual 3-dimensional lighting that the diffuse and specular lights give. So take care with the ambience, but it's nice to have it just to make sure that, otherwise you have to make sure there's some light lighting every single side of everything that you're working with. So let's set global ambient up here again. Let's just have it really low for now. Okay, so global ambient is only being added. Yeah, this is nice. It's really dark, but we can still see the structure. Well, I can on my screen anyway. And if we go to the yellow one, it's a bit clearer as well. We can see the structure here, what it looks like even when the light isn't shining exactly where we're looking. Alright, let's go back to the shader itself just to look at what we're doing. And if there are any questions or discussions on what the ideas are here. I've been looking at these lighting calculations in shaders for a while, but there's a lot happening there, so you just want to kind of make sure that I mean, as a whole it can be complicated, but if we just look at each part of this.
So in this you have the material color, and that's just one global material color for the...
In the shader, yes. So if we look at the variables and how we set them, these uniform variables we just set as, yeah, we can look at them, yeah, as just global variables in the shader. So we set these variables to some values, and once we've set them to values, those values won't change until we set them again. So we set them to values, then we send whatever parts of our 3D model or 3D environment through it. And then when we're going to draw something else in a different color or with different lights or in a different way or with a different matrix, then we simply have to set new values to this. Which is why in the display function we're always constantly calling the set model matrix over and over again, because we had to make sure that the matrix we had made and wanted to draw into next had been set into this uModel matrix variable here before we drew, because otherwise the shader would just use whatever matrix we sent it last. So the same with the colors. So if we go to where we're setting this, instead now I just have this same global ambient here. And the material specular, for instance, we can say we need that to draw this sphere here, which is the sphere that we're particularly looking at. But when we go in here, we're setting the material diffuse to a different color before we draw the yellow pyramid. We can just say, well, let's set specular to 0 here, because we don't want it to shine at all. We just want the pyramids to be absolutely matte. So now we have the shine spot on the sphere, but we have no extra kind of white addition of light on these. But we can still see the light moving around on them. If you look at them, you can see where the light moves past it, but it's only the diffuse light that is happening. The position of me or of my camera doesn't have any effect on where those shine spots are. It's actually more clear if we just make the light still. So if we go and say, let's set the light position just to a fixed position. It's still changing color. Many things are easier to see if you just have a very simple setup here. What's the error now? Yeah. I changed the name of this. Thank you. Okay. So I'm going to look at this pyramid here. You can see that it's brighter here because the light is very close to here. But I move around and nothing changes. The light is strongest in exactly the same places on the vertices on this pyramid. But if we look at the sphere, you can see the specular point moving around depending on where exactly I am. The main blue color is coming from the diffuse calculations, where the position of the light is the only thing that has an effect. But the specular point, the white light, the white reflecting light, that's coming from a relation between the direction to the light and the direction to the camera. So the position of the camera has an effect here. Okay, so now we only have diffuse on the pyramids, but we have specularity on the sphere. So now we have a bit of a light model here. If we look at the shader itself again, so we have a global ambient. For each light we have a position of the light and a color of the light. And for the material we have diffuse, which we use for diffuse and ambient, and we have specular, which we use for the reflecting light, and we have material shininess here. We can see that if we actually change the color of the light, we also change the color of that shine spot, because it was white, even though the material specular on the sphere is still 111, that is fully white. The light we're shining on it isn't white, so it's just reflecting all of the light that's shown on it. So if this is a different color, that's the light that the specularity will use. And that's also the light that the diffuse will use, but you can see it here, that this becomes a lot redder than it was, because there's more of green more of red than of green in the light that we're shining on it, but we didn't change the material of this pyramid, just the color of the light that we're using. And that color of the light affects both the diffuse and the specular calculations. Okay, so we have this light model here, and we have these functions now on the shader to set this. So vertex lighting 3D here. Okay, so questions on this, or particular parts of the code that you want to look at, because right now we're getting kind of we're at a light model that is of a fine complexity for what I expect from you in the assignment. I don't expect your light model to be more complex than this. I want you to have more than one light in it, but other than that, it doesn't have to be more complex than this. If you want it to be more general and have separate specular and diffuse and ambient factors for both the light and the material, and an emission factor for the material as well, and stuff like that, that's fine, but then you kind of have more variables to set and to experiment with. It's fun, but this is a nice simplification that kind of allows you to just think of the color as, the light as a single color, and the material as one color that it scatters and another color that it reflects. And then the ambience will just affect the color that scatters, because that's light that scatters all over the place. Anyway, so the ambient light is more or less diffuse light that's already scattered all over the place. But then you might think, or make the decision that when you set your global ambience, that's something you want to have separate from other things, because you might want to say, if I have a lot of red lights, the global ambience will probably be red. If I have a lot of white lights, but all of the objects in my scene are purplish, it wouldn't be far-fetched to imagine that the global ambience would be a bit purplish as well, because that's the light that's being reflected off all of these objects. But that's just up to you when you're kind of setting up your scene. The light model itself, as complex as it is now, will allow you any of these ideas. We don't need anything more. There's one thing, though, that we might want to do, if there aren't any questions. Or
yeah, I was thinking about one question. The material diffuse.
Mm-hmm.
That's the light that's coming off the material. Or
yeah, that's basically, no, that's the base color of the material. I'd say you're drawing an object, and I'd say the main color of the object is material diffuse.
And you're having it the same across all objects right now?
No. The objects have different colors. So the material diffuse, if we go back to making sure that we just have a white light here. For instance, the pyramids. This one is yellow, and it has no specularity in its material. So the specular calculation and the Phong and all that has no effect. It just, we might as well skip it.
So it's not shiny or anything?
It's not shiny, it's not doing anything. This color is absolutely coming from the material diffuse, just all of it. And also if we go to the other side, it doesn't show as well on the projector, but there's a little bit of yellow even in the dark spots because of the ambience. So that's being added to it.
So what if you wanted to simulate another material, or simulate the material? You would use texture, sure, but how would you simulate the color of, I don't know, like a metal, something that wouldn't really shine as well, or
yeah, it would shine differently.
Yeah.
You can actually,
Like a tire, like rubber, that doesn't shine very well.
yeah. So this here, for instance, this looks very plastic. Plastic you can do by saying I'm going to put the material diffuse to whatever color I want the plastic to be, but a pretty white specularity, a pretty white and bright specularity and a small shine point. Then you get kind of shiny plastic. If you want matte plastic, you just have less specularity. For metals like gold and stuff, you can actually just Google that. You can just go like diffuse specularity ambient for gold, and you'll probably find things. I found it in actually the textbook that I originally read. It just had a little table with a list of different materials like gold and silver and stuff, how we can simulate that. But then again, you have to make sure that kind of the material is one thing and then the environment is another, and these might affect each other in a way that you have to kind of change the material to. But yeah, you basically say I need to know what kind of light this reflects. So I guess for gold you'd have like a brownish yellow color on the diffuse, but then you'd have a really bright yellow, almost white color on the specular, and then you'd get something that would look a bit metallic. But again, textures are key to getting realistic colors. And in many cases you'd actually end up with a diffuse value of white and always just have the color in the texture. That's what's often done. Unless you want kind of the same texture but on different colored objects, you might use a texture that's grayscale and put it on top of a colored object. But in most cases, once you've added a colored texture onto something, you probably will end up having a completely white on the material diffuse, and just say the material diffuse is now dictated by the color of the texture and not by the color of the underlying material. But then the color of the texture is simply going to be multiplied into the equation and it'll have the same effect. But for specularity it's a bit different. You want that kind of to add on top, and you might want a wider specularity than the diffuse. But once you add textures, you're probably going to want to take the material diffuse just to white, just 111, and allow the texture to decide the color. But for now, while we're using it this way, material diffuse is the color of the object. Material specular is what light reflects off of it, so we can have that a bit different. Shininess is the size of the shine spot. The light color is what it is, and the light position. So we have this now. One thing we might want to add here for the material is, say, let's add material emission. So that's basically the self-illuminating color of the material. Basically, without any lights even in the scene, this color will still be added. And the way it's added is simply, okay, we calculate for each light this stuff, and then we'd add many lights, and then you can add many light 1 calculated color, light 2 calculated color here. This is done globally, so just once, the global ambient and the material diffuse, and the same with the emission. Just say U material emission, simply added to there with no regard to the light or to any attenuators or anything. So that's something you're going to want to use with care. You probably don't want anything to actually have any emission except objects that you want to glow. Like I'm going to use it right now to draw the light source, so we actually see where the light source is. So we have material emission here. I'm going to go into the shader, add a variable for that. Global ambience, material shine, material emission, location, emission location, material emission. And again, one more void set material emission, like so. And now we have this. Now we have to set some value to it. Okay, so let's just start by testing it on the sphere. We have our main sphere here. So I'm just going to go ahead somewhere in between here and say shader set material emission. Let's just set it to full red, 0, 0, 1 here. Okay. So now everything glows a little bit red, and we added that to everything. So now we want to take material emission and we want to go and say, right, when we're going to draw this stuff here, we definitely want this to be 0. We don't want this to affect these pyramids at all. And in fact, we don't want this to affect our sphere either. What we do want to do now is we want to set this material emission, to set material diffuse and specular to 0, 0, 0, 1. So the lighting actually has no effect now. And if you want to optimize your shader, you might want, when you add these things, to kind of have some checks, some if sentences in that says, if you're only using emission, then let's not actually do the calculations. If you have 0 in all of these, we actually have switches where you can say, I'm going to turn on or off the emission lighting. But for now, we'll just allow it to do all the expensive calculations even when we're not using them. Okay, so I'm setting material emission diffuse to this. Then I'm going to draw another sphere here.
Is this doing the lighting calculations for every object?
It's doing the lighting calculations for every single vertex, every single point in every object, and then it's interpolating the color between the vertices over the pixels that end up being part of that polygon. So yes, every single, like if we go into sphere graphic, we're building up this huge buffer with all these vertices. For every single vertex in here, we call the main function in the shader, this main function here, in the vertex shader once. Even if it's outside of the camera, even if it's behind something else, the vertex shader will be called for every single one. The fragment shader will not be called for every single one, because the fragment shader is called after clipping happens, which means stuff that's outside of the camera has been clipped away. And the fragment shader also happens after depth test. So if you order your polygons from closest to furthest away, then you'll actually manage to not call the fragment shader for a lot of stuff that's behind things, because you'll have something in front of it already, and then whatever's drawn next is behind something that's already there, and it'll be thrown away. But the vertex shader is so early in the pipeline that none of these checks have been done already. So yes, the vertex shader and these calculations will be called for every single vertex.
So why vertex shader?
Because there are so many more pixels than there are vertices.
So it's cheaper.
it is cheaper, but I mean, it depends also on kind of your own model that you're using to call this. The pipeline is one thing, but if you take care to not send things in there that are obviously not in front of the camera, if you have a nice way of setting up your environment so that you can cheaply tell what's possibly in front of the camera and what just can't possibly be, and don't draw those things, you can take a lot of things and throw them away even before they go into the pipeline. And if you order your polygons correctly, closest to furthest away will be best optimized, then you can actually make it so that that you go as few times into the fragment shader as possible, and then it can be, and I mean in most games now, or in pretty much any graphics now, these calculations are done per pixel. It looks much nicer, and graphics cards are powerful enough to handle it easily. But as soon as your scene gets big and your optimization isn't great and you're calling it for a lot of pixels over and over again, then it will slow down. So it is slower to have it in the, and the reason I'm doing it here is in many cases just because it's simpler kind of to look at. There's an extra step we have to do in kind of sending other data between the vertex shader and the fragment shader. But if we have time, we can look at that again. That is moving it back into the fragment shader. For now we have this, we have the emission, and we're going to draw a sphere. What I was going to do was I was going to take the same position as the light here. So we have set light position there, and I'm just going to translate to the same location. Yeah, this light color and this global ambient really don't matter here, so we might actually, well no, let's just leave it here. Add translation, like so. Okay, so I'm translating to the same spot as the light is, and I'm drawing a sphere there. I'm going to add a scale as well to make it a bit smaller, like 0.2. Let's just see how that looks. And in fact, right now we're setting this emission here. What we might instead want to do is to say, where's the light color? I'm just going to take the light color and set the emission to that. So the emission of the sphere that I'm going to draw now is the same color as the light color. So I'm imagining that I can draw the light source itself. Okay, so this light already looks a little bit more interesting when we have something there that might be the light. Let's make it even smaller. Scale it down. And now I can actually go ahead and add, where did we have this weird light color thing going on here? Just say, add this light color, and let's set the emission on this object. And obviously we're setting the emission to this, but as soon as we start drawing anything else, we set the emission to 0 again. So it's only for that object that the emission is. Okay, so now we can see the light source, and we can see its color changing depending on the lights themselves. And again, we can see that same color changing here in the shine spot, so it's starting to look like we actually have something here. Okay, the light color again, let's set it back to 1. The material emission for this, set it to 1 as well. So, and we can add the motion in again. So now let's go, we have light position here. And I'm going to take these same calculations. Wait. I'm going to make sure we... Okay. Just to make sure I'm not... Okay, let's call these S2. and we're using those for this and this, which is the color, and we're doing that here as well. Let's do, okay, so I'm going to take this position change here. I'm going to set that to the translation. Okay, so I'm just using the same calculations to set the position of the light and the translation for that object that I'm drawing as the light. Does it seem like it's positioned correctly? It seems a bit high, doesn't it? Sorry?
You have two translations for that.
Yeah. Exactly. There. Okay, this looks like a natural place for the light to be, right?
Specular is still some.
The specular shouldn't follow it. The specular should be between it and us.
It kind of, you can still see it when it's on the back of the ball.
So let's imagine, like here.
Yeah,
you can see it here.
Maybe it's okay for now, but before when the light is going behind it's weird.
You can see it like right on the edge.
Oh, okay. Maybe I was just looking funny at it.
You can start this again, so I start in the same height. It kind of appears just before, or almost at the same time.
It looks natural this way.
Yeah. If we go a little bit away, you can see the specularity kind of acting a little bit weird, but it is a reflection. If we go ahead now and say, let's just put the specular, okay, this is the sphere, materials, specular here to 0, 0, 0, 0, and just look at the diffuse, especially if we go kind of above. Okay, so this is now we only have diffuse, only the position of the light is affecting this. You can see it in kind of both images, how it's okay. So does this feel pretty much right now? This is the diffuse, and then we add the specular. And obviously this display function becomes more complicated once we have all these variables that we need to set. We need to set all of these things. Earlier, the only thing we were setting into the shader were the matrices. Those were just the transformations, so it was fairly simple. Right now we're setting all of these things, so every single object needs its color and stuff. So it's going to pay off to take these things into separate classes and say, I'm going to have a class that knows what form to, or what shape to draw. It knows it's supposed to draw a sphere, and then it knows the sphere's position and its color and all of these things. You know, then just have a handful of lights and know how to set those, and kind of separate it away. If you end up with 5 or 6 lights and all these different materials, everything inside your display function, you know, it's going to become pretty insane to handle all of this. But yeah, the code is just going to be less readable. But adding the specularity again, now looks like so. You can see it in this image as well, where we're above and a bit further away. How the shine spot is moving just a little bit, but mainly we're so far above that it's just shining off the top, just a little bit offset off the top. Whereas the diffuse is just following this exactly, always right on the side of the sphere. And in order to see it a little bit better on the projector, I'm going to take the global ambient higher as well, so you can see properly how everything is being illuminated a little bit. So even if we go to the other side of everything, we still have more or less some reference for the shape of it. So yeah, this is being lit, but we can also see the shape of everything that's here, rather than it just being completely black. So we have the ambience giving us the general shape of all the objects from any side. We have the diffuse giving us the 3 dimensions of the objects. So we have good 3D. And then we have the specular, which gives us this, well, kind of more of a feel for the material, how shiny it is. And right now this is just entirely very shiny, and this is just very, very matte.
The specular on top of the sphere in the right frame
Yeah.
really looks done, or at least not right.
Alright, maybe if we just make the shininess a bit more, I mean, you can just experiment with the values here. So if we go ahead for the sphere here and say let's put the shininess again to this really high number that we had earlier. Yeah, it's a bit bright, especially considering how matte.
Because it's supposed to be it's orbiting directly around the sphere, but
yeah, but this is where the light source reflects off of this surface and into the camera. That's where this light happens.
Seems like kind of an really extreme angle.
Yeah, it does. Sometimes it does seem extreme, but the calculations, I mean, either they're right or they're completely weird, and in this case I'm pretty sure they're right. So, but yes, in some cases this is kind of weird. It looks more like someone's shining a separate light on top of that.
Yeah.
So if I saw this scene, I'd say I'd go ahead and experiment a little bit more with my values. This isn't great. We're doing extreme values right now, so experiment with this, and yeah, just go ahead and build on top of this lighting model.